Hey, what's up guys, it's Simon. It's really raining pretty hard at my house right now in the midst of a storm, but I'm still doing coding interviews, questions, stuff. So today we're doing linked list cycle 2, and if you didn't watch my video yesterday, you're going to want to go ahead and do that because this YouTube series is a bit of a linked list itself. Alright, I'll kill myself for that joke. Yeah, so basically what we're adding on today is that we have to find out where the cycle begins, whereas yesterday we just had to determine whether there was a cycle in the linked list. So like for this first example, we need to return index 1 because it's 0 index. So that's where the cycle begins, as you can see. And here we'd want to return 0. So yeah, and here we'd return null. So perfect. So let's do some input validation. Okay, now let's create our list nodes. And now let's create a while loop to iterate through them. So remember, if we find a null value in this linked list, then we know for certain that there is no cycle, so we can just simply return null. Otherwise, we're going to increment them, and remember we're incrementing the fast by 2 and the slow by 1. And then if slow at any point during that slow equals fast, then we are going to create another while loop where slow is not equal to head, actually. And you're thinking, oh wait, why are we talking about head again? Well, my way of solving this problem is this always works out that wherever the slow and fast pointer meet, so say they met at 0, then the distance from there back to 2, or the start of the linked list, is, well, they would meet at -4. So say they meet at -4. The distance from there to the start of the linked list to the start of the cycle, and the distance from the place where they meet to the start of the cycle will always be equivalent. So we simply increment head and increment slow, and then where they meet is the node that we're going to return. I explained that horribly, but I think you'll probably understand what I mean when I show you in the code. So this always works out that setting slow equal to slow.next and head equal to head.next, the distance from them to the start of the linked list cycle will always be the same. So where they meet, once they meet, we can just return slow and be done with it. We could have put fast into there, but it doesn't really matter. As long as we increment it by 1, I'll just put slow in there for clarity's sake. And then boom, look, it works out. So let's submit this. And yep, accepted. So yeah, the way to solve this problem is to realize that from the head to the start of the linked list, and from the point where the slow and fast pointer meet, because we're incrementing 1 by 1 and the other by 2, the distance from those points to the start of the cycle will always be equivalent. It might not always be 1, but it will always be equivalent. And so as you can see, it passed all the test cases. So you simply just increment them both with this while loop, and then where they meet, you return that point. So yeah, this is the extra logic that we added on today. So thanks for watching, you hosers.